Okay, welcome to Bhai Vision, and I'm continuing my series that is RE-NEET physics paper explanation. I have uploaded video 1, that is part 1 of this explanation, in which I have discussed about and explained all the questions from 1 to 6. So in today's video I will discuss from question number 7 onwards. So in today's video, I will explain each bit of the questions that have been asked in RE-NEET June 2026. So I think I will explain from basics. So we so focus here and learn what I am teaching. So I can explain in Hindi also. So if you are comfortable in which language, then comment me. I will continue in that language, English or Hindi. Okay. So come to the question number 7, that is in Gregor Marsden experiment, the number of scattered alpha particles, that is n theta, is plotted as a function of scattering angle theta. So here we are asking about Gregor Marsden experiment, or this is simply what Rutherford's gold foil experiment. This is not in other experiment. This is the exact experiment, that is Rutherford's gold foil experiment. So here we have been asked to draw the graph between n theta versus theta. So we know the formula of scattering, that is n theta is directly proportional to 1 by sine to the power 4 theta by 2. So I can say that when theta is equal to how much? 180 degree. Then theta by 2 becomes 90 degree and sine 90 is 1. That means n theta is nearly equal to 1. But when theta is 0, that means on logarithmic scale n theta, when theta decreases from 180 degree to, okay, as you can see, n theta is directly proportional to 1 by sine to the power 4 theta by 2. So okay, I consider when theta equal to how much? 0, then sine theta by 2 is also 0, then sine to the power 4. That means this is nearly equal to n theta is nearly equal to that much, how much? Infinite. This is a very large number when theta equal to how much? 0. So I'm considering when we are increasing the theta, then how much the n theta will be. So when theta approaches to 180 degree, that means theta by 2 becomes approaching to 90 degree, and sine 90 is how much? Sine 90 is 1. Then 1 to the power 4 is also equal to 1. That means n theta becomes 1. So I can say that, or we can say that when theta increases from 0 to 180 degree, the n theta drops from infinite to 1. That means from above graph we can say, which is starting from infinite, the graph number 2 is starting from very high point and it drastically drops to 0. That means 1, not 0, that is 1. Okay, here the discussion, the detailed explanation is also I written on it here. Okay. Okay, proceeding to the next question, the 8th number question. Consider three medium PQR with refractive indices 1, 1.25 and 1.5 respectively. The medium Q having a thickness of 5 centimeter. That means this is the medium Q, is placed between extended media P and R as shown in the figure. So it must be P, that means refractive index 1, and this is refractive index 1.5, that is PQR. Okay, the apparent depth of O is H1 for similar observation. Okay, we viewed from medium P near the normal direction, the apparent depth of O is H1. Okay, he is saying that this is H1 and this is H2, and the O point is exactly at the midpoint of what is the P medium, Q medium. So we have to find H1 minus H2. How can we find? If we find H1, then H2, then we can explain or find the calculate the H1 minus H2. So here we know the object O is at the center of the medium Q. The medium Q have the thickness 5 centimeter. So we can say the actual depth from both sides is D equal to 5 by 2. 5 centimeter by 2 that is 2.5 centimeter. Okay, when viewing from medium P, that is we are calculating for H1. When we are viewing it from point P or medium P, we can say that we know the actual, or we can say the apparent depth. Okay, light travels from denser to medium or rarer medium. So H1 is how much? D, the actual thickness or actual depth into what the an observer refractive index of observer by refractive index of the object, that means in which medium the object is placed and in which medium the observer is. So we know the actual depth is 2.5 centimeter. Then we substitute an observer that is in P medium. Here an observer is 1 and an object is 1.25, then 1 by 1.25, or we can say that this is H1. 2 centimeter is the H1. Now we are going to calculate H2 when viewing from R, that is we are viewing from downside R to the upper part, that is Q. So here H2 is equal to the actual depth D into refractive index of the medium in which observer is placed and the refractive index of the medium in which object is placed, observer by object. So 2.5 is the actual depth into observer in which medium, that is 1.5 by 1.25, that is if you calculate this is 3 centimeter. So now calculating the required absolute difference, that is H1 minus H2, that is 2 minus 3, it is minus 1, and the mode of minus 1 is equal to how much? 1 centimeter. So this is the exact solution of this question, and this is quite good, not that much lengthy. Okay. Now going to the problem, question number 9, that is consider that delta S, sorry, sigma S, KB and BR represent Stephen Boltzmann constant and Boltzmann constant and Wens displacement constant respectively. The dimension of this function is what? So we have to find dimension of each of this and then multiply with it. Okay, we know what is Stephen Boltzmann constant. That is, this is a tough question. So you have to remember all the dimensions. Then we can solve it. But we can derive it from simpler formula. That is, we know what is Stephen Boltzmann constant. In which formula it is? It is the energy is equal to sigma s into t to the power 4. So it is like power. So we can say that E is the power. So we can calculate it as delta, sorry, sigma S equal to power. Power, that is power per area. We can say also this is energy. So power per area is this much and T to the power 4. T to the power 4 is this, temperature to the power 4. So we are calculating this. This is the exact dimension of sigma S. Then Boltzmann constant Kb from energy Kbt, energy equal to kbt, then kb equal to how much? Energy by temperature. Kb equal to energy by temperature. The dimension of energy equal to ml square t minus 2 ml2 t minus 2. So calculating this we have kv, and now the last part, that is Wens displacement. We know lambda t, wavelength into temperature is equal to v. Then this is length and this is temperature, so b equal to lk. Now multiplying each term, we finalizing the final term. This is so on multiplying each of the term, we found that the this function, that is sigma s kb to the power minus 1 when into b, have the dimensional formula L to the power minus 1, T to the power minus 1 and K to the power minus 2. So I will consider this question as tough. Okay, I think there is some issue. Okay, now coming to the question number 10. So here we have given for sound waves, if the number of notes is fifth harmonic for an opponented, that is 5 for opponented and pipe and n N and that for ninth harmonic of the same pipe with one of its end closed. So ninth for what? That is close ends. Then find N by M. Okay. So he is asking to find out the ratio of the nodes in open pipe to the closed pipe. Okay, for open organ pipe, nth harmonic has n nodes, that is n equal to n. That is here we have a fifth harmonic nodes, that is n equal to 5. We can say it is clear. But now coming to the close end pipe. For close end pipe, the formula changes. That is number of nodes equal to n plus 1 by 2, and here n is given 9, that is 9 plus 1 by 2 equal to 5. So if we are finding n by m, then n equal to 5 by m equal to 5, and the answer is n by m, that is 5 by 5 is equal to 1. Okay, now coming to the 11th question. Two infinitely long parallel conductors wires of length of A and B. Okay, current flowing I and 2A respectively in the same direction. The where A has uniform mass per unit length. A has uniform mass. So this is A and this is B. Okay. The current flowing in A is I and current flowing in B is 2I. Okay. The same direction. Both are flowing in the same direction. That means here attraction will happen, and we are fixed this part, that is B where is fixed, and the uniform mass per unit length is lambda. Mass per unit length is lambda. On an insulated floor, the where B is kept fixed at a height h. So the height of the where h B is h. Okay, the minimum magnitude of h so that the where a does not rise from the floor. So we are asking to find the value of h, the minimum value of h for which the A will not float, not go upwards. So how can we find that? So we have to find the force, that is magnetic attraction force, and which will balance by the gravitational attraction force or weight of the wire A. Since both wires carry currents in the same direction, they experience attractive force. I already told you. The magnetic force per unit length Fm is how much? We know mu naught I1 I2 by 2 pi. But per unit length, that means mu naught I1 I2 by 2 pi into h. That's why we can say mu naught here I1 equal to I and I2 equal to 2I by 2 pi h. So we got mu naught I square by pi h. So this is the expression for the magnetic force of attraction per unit length. Now we have to find what the weight of where A per unit length. This upward attractive magnetic force acts against the downward gravitational force per unit length on where A, that is Fg, which is given by Fg equal to how much? That means mg, but mass per unit length is given lambda and the gravitational acceleration is g, that means gravitational force is lambda g. So for what condition the wire will not levitate or not attract to upward? When Fg, that is gravitational force, is greater than or equal to Fm. That means Fg, that is lambda g, is greater than equal to mu naught I square by pi h, or we can say that h, you can calculate it cross multiplying h, h is going left side and lambda is coming to the bottom of this. Then h equal to how much? Mu naught I square by pi lambda g. This is the exact answer. So we have how much? This is mu naught I, sorry, the option is mu naught I square by pi lambda g, that is the first option. I think you all are clear about this. Okay, now coming to the 12th question. So in 12th question, the voltage B is given 220 sine 2 into 10 to the power 3 T volt is applied to a series LCR circuit. So series LCR circuit, then the current amplitude in this circuit. So we have to find I. We know V equal to IR or I equal to V by R. So what will be the V? V is the total amplitude of voltage, that is 220 by R. Here LCR circuit, so we have to find impedance, that is total impedance. So now we have to find the total impedance. So comparing the voltage equation V equal to V naught sin omega t, we can say that V peak is 220 volt and angular frequency omega is how much? 2 into 10 to the power 3 radian per second. Calculate the inductive reactance XL and then we have to find XC. XL equal to omega L, that is omega into L is given, that is in which here L is given 10 milli Henry, that is 10 into 10 to the minus 3 equal to 20 ohm. So we have found XL. Now we have to found XC. XC is equal to how much? 1 by omega C. 1 by omega into C. And C is given 25 microfarad. 25 into 10 to the power minus 6. So this is also 20 ohm. And we know when XL and XC are equal, the circuit is in resonance. So or if we have to find Z, and we know the formula, Z equal to how much? R square plus XL minus omega C square. We know XL, we find out XL equal to XC, so this term will be becomes 0, so only R square term will be there. And here R is given, that is how much? R equal to 100 ohm. Then we have to find what is 220 by Z, or Z equal to R, that means 220 by R, that is 220 by 100 equal to 2.2 ampere. So this question have answer 2.2 ampere, that is option number 4. So I am stopping this, ending this video right here, and we will continue from question number 13 onwards.